Okay. Hello, I'm Corey Van Vilden.
And I'm Taylor Rose. And in this video we will demonstrate, describe, and provide a practical application of this photocell theremin, which we've designed for our supervisory control and data acquisition class at UW Green Bay. In a practical application, these photocell signals will be monitored at the master station from a distance and from multiple locations. Using the myDaq software, we would log the sensor's activities to maintain a desired range, determine any form of pattern in which the behavior is out of specification, or perform maintenance checks for things such as periodical replacement. The software would utilize multiple high and low alarms. Depending on the sensitivity of the alarm in question, only a high-level SCADA engineer within the master station would be allowed to acknowledge and/or designate the appropriate corrective action. The high-low alarms would indicate that either the amplitude and/or frequency are above or below the desired range. The portion of this demo in which we will simulate a flashlight would in all actuality be a constant stream of light that is either increased or decreased by the operator's hand to achieve the desired response.
Okay, so basically, what does this all mean? We created a theremin, which is an electronic instrument. You usually play it with your hands in the air. This one is light sensitive, so it has 2 photocells in the circuit, and depending on how much light is hitting those photocells, it'll either change the pitch of the square wave that's made by the Arduino, or it'll change the volume that's going to the amp. We're using a small little guitar amp in this case. And so then we're monitoring that signal with our ears. You'll be able to hear it. You also can see it on the oscilloscope. And then we're using the myDaq to log the data basically so we can analyze it afterwards.
And as the data is logged, it creates an Excel file that we can visually go back and see the exact values at a specific time.
And if you so desired, I mean, you could set this up so it would trigger an alarm if the volume was too loud or too low, or if the frequency was too high or too low. So that's basically our SCADA application. So this is like a simulation of something in a factory setting. This could be like a machine, and I don't know. Let's just do the demonstration and maybe it'll make more sense. Okay. So here's the circuit. I'll turn the light on so you can see the circuit. This is the Arduino. This is the first photocell. This is basically creating a voltage divider, and that goes to analog in 0. So the voltage reading on this returns a value from 0 to 1024. That in turn goes to the sketch. Show this sketch here. And then according on that reading, it maps it to output frequency, and it'll play a frequency based on this tone sketch right here. Okay, so that creates the pitch, and then this other photocell is basically shorting the signal to ground. So if it has a lot of light on it, or is it the other way around? Anyway, this photocell,
as the light is increased, it'll decrease the volume.
Right. So it works best in the dark.
So we will be unplugging the light.
Oh, here's also this is also a schematic of the circuit, basically what's going on here. This is a simulated pulse voltage that is what's coming from the Arduino, and this is going to the guitar amplifier at the end. Photocell 1 controls the pitch, photocell 2 controls the volume. And okay, so I'll turn off the light here. Turn on the amp. Okay, first I'm shining it on the first photocell, which controls the pitch. As I get closer, the pitch goes up, as you can hear. Next, I'll shine it on the volume. You can hear that the volume goes down almost to nothing. Yeah, and then while we're doing this, did you show the oscilloscope? You can see it on the oscilloscope too. Frequency gets lower, frequency gets higher, and the volume also goes up and down. Alright, and we're also showing this on the myDaq data logger. So now we're going to start that. That's a high frequency, low frequency, and I'll show amplitude modulation. Okay. So now that, I don't have the Excel document up, but what it does is it logs all the data that we just recorded to this file path, and then that creates an Excel document that you'd be able to see and analyze afterwards. So,
and the length of the Excel file is varied by the sample rate, which on a default is set up to happen every 10,000th of a second.
1,000 samples a second right here.
Which makes for a very long Excel document.
Yes. But yeah, that's basically it.
That basically concludes our SCADA application and demonstration.
Thank you.
Thank you.